So hopefully you remember slope, right? And we can do slope, which is the measure of the steepness of a line. But the tricky thing is it only works for lines. We had all sorts of ways to talk about slope, right? We did everyone's favorite rise over run. We did y2 minus y1 over x2 minus x1. Or probably my favorite, and this is one I want you to get a little more familiar with, is delta y over delta x. So delta means change. And so this is how much does the y change compared to how much does the x change. Now we're going to extend this idea of slope to other graphs, okay? And so let's look at an example here. But I'm not going to call it slope anymore. I'm going to call it the average rate of change. In other words, how much does the graph change? So if I've got a graph, say it does something like this. I'm going to mark off some points on here. So I'm going to put those 2 points, and then I'm going to put, oh, let's put one up here. So, I don't know. I'm kind of winging it. -8, 6. -3, 6. And what would this be? Oh, let's call it 10, 10. Okay? And I can talk about the average rate of change between intervals on this graph. So I can look at the average rate of change from -8 to -3. So I'm looking at it on that interval. Now, we aren't going to use the slope formula anymore. We are going to change it up a little bit. We are going to use the formula for average rate of change. Here's how we do it. We've got 2 ordered pairs. And we could call this one A and f of A. And we could call this one B and f of B. Of course, assuming that the name of this function is f. If it wasn't, we'd have to pick a different letter. So here's what we're going to do. To calculate average rate of change, I am going to do a variation of the slope. I'm going to figure out how much the y's change. And so to find the change in y, I'm going to do f of b minus f of a over b minus a. Okay? So that's going to be my formula. Now, f of b, in other words, in the second ordered pair, what is my y value? So I have 6 minus 6, and I picked that for a reason, so stay tuned, over -3 minus -8. And eventually we get 0 over 5. In other words, my y change was 0, my x change was 5. So ultimately, my average rate of change is 0. Now, does that mean that this graph was completely flat, horizontal, perfectly from -8 to -3? No, that's not what that means. But on average, it did not change. Okay, so that's something we have to be a little bit careful of. The other interval I wanted to look at was, let's look at -8 to 10. Now I'm just talking about the x parts when I'm writing these intervals, right? So this is an interval a to c, so I'm going to call this point c and f at c. But intervals, I tend to just use the x's, and then the y's just kind of come along for the ride. So same idea, f at c minus f of a over c minus a. So f at c is 10 minus f of a is 6 over c is 10 minus -8. So if I do this, I get 4 over 18, which simplifies to 2/9. So on average, my average rate of change is I rose 2, ran to the right 9. Now, we could, if we wanted to think of it in terms of slope, we would have to think about visualizing a line between those 2 points, for example. Or I'm too nervous to draw a line connecting all the way across, but that's when we would actually talk about it in terms of a slope. So the slope of that green dashed line is 0. The average rate of change on that interval is 0. So same idea, but just a little bit different language around it. So take a look at that, let me know what you think, and we'll keep plugging away.